Welcome back, learners. So now jumping to our application questions that are still based on the generation of electricity. So to begin with the application questions, we need to look at this picture given to us and we need to name the parts that are labeled A to E that are in this diagram. So we have A, we have B, we have C, and we have D, and then lastly we have E. We need to be able to name all of these parts that we are finding in this power station. So A, what is A? A is our boiler or our furnace. That's where basically we are burning that coal that is being inserted or through the conveyor belt. And then once that coal burns, remember it is going to produce steam, and then that steam, that coal is going to burn, which is going to heat up the water. That water is going to heat up and produce steam. That steam is going to enter the turbine and then turn the turbine, which is our part B. As that turbine turns, it will therefore keep on turning and turn, and as it turns, it's also going to be making the generator to also turn, which is part C. Now, as this generator turns, it is going to produce the electricity. Now, remember, this electricity, it can either be produced at a very low voltage or also at a very high voltage. So therefore, it is then going to be transported through the power lines, as we are seeing there. It is going to be transported through the power lines. Now, if that electricity is produced at a very high voltage, something needs to happen. It needs to either be stepped down if it's produced at a high voltage, or it needs to be stepped up if it's produced at a very low voltage. So those are the functions of the two transformers. That one, it is going to increase the voltage if it is a very low voltage, and the other one is going to decrease the voltage if the voltage is very high. Then E. Now once that water has made the turbine to spin and also the generator to spin and the electricity to be produced, it needs to go back to the furnace where it is going to now be boiled again to redo the whole process again. But then before it can go back, it needs to pass through E. E is your cooling system, whereby now that water is cooled down and therefore it goes back to the furnace where it is going to be burning and then going to be producing the steam and then restarting the process over and over again. So this is our parts that we need to be able to label when we are looking at our power station. Next question. We now need to name 3 disadvantages of using coal or other fossil fuels for electricity generation. So 3 disadvantages. We can look at the following. Remember they said 3, so any of these 3 will suffice. So number 1, when using coal, there's going to be air pollution. Remember, this is the burning of coal or any other fossil fuels. We can produce the CO2, which is our greenhouse gas. We can also now produce the NO2 and also the SO2, all our oxides, and these are very dangerous to the environment. We can have acid rain being produced from some of these substances that are being produced. Even the global warming can also be produced as also one of the disadvantages there, and also the acid rain as also one of the disadvantages to say. When we are burning coal or any other fossil fuel, there's going to be air pollution that is going to be produced, or just pollution. We can also have acid rain, which is going to be now a result of the SO2 dissolving in the atmosphere. We can also have global warming, which is going to be the result of the overproduction of this gas, the carbon dioxide, and even the environmental health impacts. Now remember that the acid rain can now damage the plants, it can also damage the buildings around us, and therefore it can cause negative environmental impacts and even the health or the negative health impacts when it now starts to damage our plants and therefore causing diseases over time. Number 3, we now need to name 4 alternative sources of energy that can be used for electricity generation instead of coal. So instead of coal, what else then can be used to generate the electricity? Remember, we can have all of these 4. Number 1, we can use water. to have our hydroelectric plant. We can also use our wind for our wind power, and also our solar power, and also lastly our nuclear power. Now remember that all of these alternative ways of generating electricity, they also have their own negative impacts depending on which one we are looking at. Now we know that with the nuclear power, we can produce radioactive material as the waste product, and therefore that can cause cancer to people around the area, and can also cause the environment in that particular power plant to be radioactive for thousands and thousands of years. We also know that with regards to water, South Africa is actually a dry country. We do not really have that much water that we can use to generate the electricity. With regards to wind, with wind, for us to build the windmills, the material of building the windmills is very expensive and also requires a large space of land for us to be able to build and erect all of these windmills. And also remember, without wind, if we have a day where there's no wind, or even a week possibly where there is not enough wind, there won't be any electricity that is going to be generated. And therefore, that's also one of the disadvantages. Now, with regards to the solar power, same as wind, if there is no sun, we can't produce the electricity. And also, with regards to the parts that are required to build all the solar panels, they are quite expensive. So therefore, those are some of the disadvantages of using these alternative sources of generating electricity. Now, question 4 is asking us, what is the purpose of the following in the national electricity grid? The first one is a step-up transformer. And also, we should know that basically that's the question. That's what the question is asking. We should know the function of a step-up transformer. We do know that as the electricity is generated on the power plant, as it is being transported from the power plant into the cities, into the factories, it can be transported at a very high voltage. Also, it can be transported at a very low voltage. Now, should it happen that it gets to the factory at a very high voltage, then before it gets to the factory at this very high voltage, it needs to be stepped down so that it can be just the right amount of voltage. Now remember, the right amount of voltage that we are using is between 220 to 240 volts. Now, should we now transport this electricity at, say, for instance, a voltage of 260 volts, now, obviously, we cannot be able to use it because what we are able to use is between the range of 220 to 240. If it's transported at this amount of voltage, therefore, it needs to be stepped down. And how is it going to be stepped down? It is going to be stepped down using a transformer, in this case, a step-down transformer. However, if it is transported at a very, very, very low voltage, let's say now at a voltage of 200, obviously, we still cannot be able to use this voltage, so therefore it needs to be stepped up. And the only way that it can be stepped up is through the step-up transformer. So therefore, to answer the question, the function of a step-up transformer, it is to increase the incoming voltage by decreasing the current strength. So this increasing of the voltage is done by decreasing the current strength. So when the current strength decreases, the voltage is going to increase. And likewise, by looking at the step-down transformer, what that does, it is going to be decreasing the incoming voltage by increasing what? By increasing the current strength. Now remember, we have said that the relationship between the current strength and the voltage is inversely proportional, which means that when the voltage increases, the current strength needs to decrease. However, should the current strength increase, then therefore the voltage must decrease. So that means the relationship between the current strength and the voltage is inversely proportional, which then means when the current strength increases, the voltage must decrease. However, if the current strength now decreases, then the voltage must increase. So with all of that said, learners, we're just going to quickly go for a short break, and I will see you just after this.